Saturday. Was it Saturday? Yeah.
Neither of us did as well as we thought we had.
So,
We didn't do as well?
No, the homework, like the individual homework, we were talking about it, and we both were not happy with our score. Were you happy with your score?
I got a B minus, so I was happy.
that's awesome.
Yeah, I was surprised. That's what I got too, but I was very surprised at it because I understood the material. But
Oh. My test scores are the worst, so if it's like a C or above, I'm golden. I'm happy with it.
all right, guys. So the first question in part 2, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? I actually checked that one on. What are the 3 assumptions that need to be checked? First, we go through the individual preparation thing.
Okay, hold on.
Yeah, sorry, we go over that first. I actually had to look this up because I could not, look it up on the answer key because I could not remember. But apparently a simple random sample was drawn from the population, the distribution of the sample mean is normally distributed, and sigma is assumed to be known.
What's the sigma?
Standard deviation.
Oh, okay, that's...
They just want to make it confusing.
Okay, the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. A BYUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for these 50 students is 541. Assuming the population standard deviation of 32, answer the following questions. What is the point estimate for the population mean? Isn't it just the mean?
Yep.
Okay. Oh, excuse me. Create a 95% confidence interval for the population mean. Show all your work below.
Okay. That's where you plug in all the little letters, right?
Yeah, that one has letters.
The Z and the... Excuse me.
Okay, I did not do this, you guys, so I don't have any of the math.
Okay. Do you want to do it, Mariella, or do you want me to say
it? You can go ahead and take it, because I need to open up the formula again.
Okay, so what you do is you're trying to get both sides of it, because the confidence interval tells us what's between, 2 standard deviations or so. So it's going to be 541, the mean, minus the confidence level, which we're going to use as 1.96. You figure that out when you type it into the normal probability applet.
That's the z-score, right?
Yeah, and then it's going to be times 32, so the standard deviation, divided by the square root of the sample mean. So that side, I got 532.13. And then the other side is the same thing, except instead of subtracting it from 541, you add it to 541. So I got 541.
Rebecca, do you divide the whole thing by that number?
By what number? The square root of 50?
Yeah.
Usually, what I've been doing is I just type it all in and it comes out correctly. So.
Okay. Okay, that makes sense. Okay, are we ready to move on?
Yeah.
Okay. Okay, say the sample size is changed to n equals 100. Now compute a 95 confidence interval with the same point estimate. So you just plug in the square root of 100 instead.
And the numbers that I got are 534.73 and 547.27.
According to the answer key, that's right. Okay. Do you want to read the next one?
I'll read it. So how does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95th% confidence interval of sample size 100?
The larger the sample size, the smaller margin of error there is.
Yeah, that's what I said too.
Okay.
Create a 90% confidence interval for the original 50 students. So you do the same thing, except instead of 1.96, you put in 1.65.
Wait, say that again. Instead of 1.96.
You put in 1.65.
Okay. And since that's, oh, just kidding. Never mind. Just kidding. I got it. Okay, 12. How does the margin of error for the 95% confidence interval that you computed in part 2 compare to the margin of error for the 90% confidence interval that you computed in part 5? Okay, the level of confidence is just the standard deviation, right?
Nope, the level of confidence is the 90% or 95% or 99%.
Oh, okay. Okay, well, that gets smaller. The margin of error still gets smaller.
Yeah, the margin of error gets smaller as the level of risk gets smaller. That's what I have too. You want to read the last one, Marielle?
Yeah. So the BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in this sample to ensure he has this level of accuracy for a 95% confidence interval?
Can you solve it?
Let's see, how many students were there in the first place?
Or 50.
50, right? No, I'll need help on this one.
Okay, I'm trying to figure out how I can bring this up because it's so hard to just. Is there a way I can like type on the screen, or do I have to share my screen? I have to share my screen. Okay, we can do it that way. Good job, proud of you. Sorry, he's been working on this project like all day.
Oh.
It's done. He just figured it out finally. Okay, why won't it let me share my screen today? This is frustrating. It usually works. Okay, I'll just have to type it. So what we're figuring out is you figure out the margin of error. So it's m equals the z, which is the level, the confidence interval, which is 1.96, minus the standard deviation, which is 32, divided by the, oh, how did I figure that out? Divided by, oh, 5. Okay, we want the margin of error to be 5. So divided by 5.
Okay.
And the answer that I got was 79.
Okay. Can you repeat that same steps, the same formula again?
Yep. So it's the z, so the 1.96 minus the standard deviation, which is 32, and then divide it by 5 because that's what we want the margin of error to be.
Okay.
Perfect.
Let me make sure that that's actually the right thing that I just told you. And it's not. That's not what I did. Oh, yeah, it is. Sorry, I'm just trying to make sure that I got this right. And that is not how I solved this problem earlier, apparently. Give me just a second, guys. Oh, right, I forgot a step. You have to square it.
Oh.
I need to do some figuring for a minute. Okay. I did something wrong, and the answer key doesn't have this answer. Give me just a minute. I will try to figure out what I'm trying to tell you that I did.
You were fine.
Let's go back through the calculator. Earlier. Do you have this answer in the answer key, Cassie?
What?
Is this answer in the answer key?
The 158?
Yeah, it says 158 for.
This is 158? Okay. Then, go back down. Okay, yeah. All right, so what I was telling you was right. You just have to make sure that you square it at the end.
Oh, okay.
So you do 1.96 minus 32 divided by 5 squared. That's the stuff I was skipping.
You're good.
Okay, hold on.
Okay. Are we ready then? What?
Are we ready to take the quiz?
Yep.
Yeah, so what did you get for that last answer, Rebecca, when you do the 1.96 minus 32?
Well, you're going to get 157.35, but when
Yeah.
into that, you don't have 0.35 of a student. You can't, like, do that, so you found that.
Unless she's pregnant or something.
All right. Let's do this then.
Okay.
I'm going to go ahead and push start.
Okay, are we ready?
Yep.
Yep.
Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25.
Okay.
There's so much math. Ugh.
Do you know how to do it?
No, because I didn't do the individual preparation, so I have to go back.
Okay. I didn't want to start walking through it if you already knew how to do it.
No.
No. Walk through it, Rebecca.
Yeah.
So the very first thing that you have to do is figure out what the 90 is. You'll learn that really fast because you have to do it in your
Okay.
preparation. But in order to figure that out, you go to the normal probability applet, and in the area part, you put in 0.9. It's finally going to let me share my screen. Yay, that excites me. And then the z-score, the positive one, is the number you're going to be using from then on.
Okay.
So you'll do that. So I know that the first number I'm going to need is 1.65. And then, I lost the quiz. So if it just wants the margin of error, then it's going to want the 1.65 minus 50 divided by the square root of 25, which we know to be 5. Nope, not minus, times. I'm sorry.
Plus.
That makes a whole lot more sense.
I got 16.45.
Me too.
Yeah?
But he wants 3 decimal places.
So
0. 0.450 then?
Yeah. I guess, like, I know that's how to do the assignment, but
I think it's fine.
okay. Which of the following statements is true? Mu is a point estimator of x. Standard deviation is an interval estimator of square root of standard deviation squared. X is a point estimator of mu, or standard deviation squared is an interval estimator of x. So I'm pretty sure it's the third one. I'm going to go look it up.
Okay.
Okay.
that's
X
awesome.
is,
How'd you do that with your camera? How'd you set it up?
oh, you push the, still sharing, it shouldn't be sharing anymore, but the little green button on the side. I don't want to be a piece of math anymore. Okay, whatever. So a point estimator. Yeah. So it is the third one.
Okay.
The X is used as a point estimator for the mu. Okay. You want to read the next one, Mariella?
Yeah. Let me get there. Gina wants to construct a 95% confidence interval for the GMAT score. Sorry. She knows the standard deviation is sigma equals 113. She collects a simple random sample size of n equals 64 and computes 526. Uses information for questions 5 through 8. So what's the lower limit of this confidence interval?
So we put the 95 in the normal, or the probability applet to get the z-score, right?
Mm-hmm.
Okay. I don't have the normal probability applet up, so what is
Okay.
it?
It's 1.96.
Okay.
Yeah, is that the one who went over the video?
Yeah.
Yeah.
So we do it the same way as we did before.
Yeah.
Hold on. What am I doing wrong? Here, let me show you. What's
11.8.
Okay, that's not what I got.
Oh no.
Okay, so what are we doing differently?
I did 1.96 times 64.
That's what we're doing differently. It's times the standard deviation and then divided by the square root of the sample size.
Oh, I had it backwards.
no? Okay. Did that work out?
I got 27.685.
That I got too. And what it's asking, since it's asking for the lower limit, we have to do the mean minus that. And Mariella, what you need highlighted in order to get the right answer is just the middle. So highlight that middle section and then type in 0.95.
Ah, that's what
And you get the right answer.
The mean is the 526, right?
Yeah.
Okay, so we minus that.
Yeah, we do 526 minus 27.685.
I'm so sorry I'm not prepared, you guys.
It's weird when we do things out of schedule.
Oh my gosh.
Okay.
Okay, so 498.315.
That's what I got too.
Okay.
Are you there, Mariella?
The lower limit of this confidence would be 400 what?
98.315. Did you see how we figured that out?
98. No, I was trying to fix my thing. So you did that 1.96 and then divided or minus the standard deviation, isn't it?
No, times
Right.
the standard deviation.
And then divided by the square root of, so
Yeah. And then once you have all of that, you're going to subtract that number from the mean to get the lower limit.
okay, so then you get the 498 point. Did we have a point? Decimal?
Are we on the upper limit yet?
Yeah. And that's exactly the same, except instead of subtracting that number, you're going to add it to 526.
Yeah. I got 553.685.
Me too.
Okay.
0.685.
Yep.
So you did the same thing minus the mean?
We did the same thing, except that instead of minusing it from the mean, we added it to the mean.
Okay, we're adding, right, because we subtracted it last time. Okay, never mind.
So lower is subtraction and upper is addition. Okay, are we ready?
Yeah.
What would happen to the width of the confidence interval if Gina increased the sample size? It would decrease.
Yeah.
Yeah?
I think so. I'm looking it up again.
Okay.
If
Because
she decreased it, what's the question? What would happen if she increased the sample size?
Yeah.
Yeah.
Increased.
Yeah, then the width would decrease.
Okay.
And what would happen if to the width of the confidence interval if Gina changed it to 99% confidence interval?
It would still decrease.
It would increase.
Why?
Because the textbook says increasing the confidence level will lead to larger values of Z. If Z is increased, then the margin of error would increase. This would lead to a wider confidence interval.
Mm-hmm.
Listen to the textbook. Okay. Oh. Rebecca, do you want to read the next one?
Yeah. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulb. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? So that's the thing we did earlier where we had to square it.
Yeah.
Where we did 1.96 times 400 divided by 50 squared. And I get 246 after I round up.
That is not what I got.
Okay, what did you get?
Hold on. 1.96 times 400.
Divided by the square root of 50?
Nope, just divided by 50.
Oh, okay.
I got 15.68.
And then you have to square it.
Square the answer?
Yep.
15.68.
Okay, I got 245.
0.8624.
Yep. Right, so you round it up to 246 because you can't have 8/10 of a person.
Okay. Next.
Okay. The mean salary actually is mu equals 100,000. The standard deviation is 36,730. You're interested to know if the mean salary for women actuaries are different or is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a significance level of 0.05. You collect a simple random sample of 36 women's salaries and find that X equals 111,000. What is the lower limit to this 95% confidence level? So
There we go.
we do 1.96 times 36.
That's the sample size. The standard deviation is 36,730.
Oh. Wait, why is it this?
Wait, aren't you just doing the 1.96 times the 3673.0?
Yeah.
Okay.
Because
And then dividing that by
36, right?
the square root of 36, yeah.
okay.
I'm so nervous about this. I'm so nervous that I'm going to have been giving you guys the wrong answers the whole time.
That's okay. Like, really, it is. Yeah, you're fine. Okay. I got 11,000.
Did you get 11,998.5? Because that's what I got.
Yeah.
And then we have to subtract it from the mean to get the lower limit.
Yeah. Okay.
So what did you get for this one?
The actual answer I got is 88,002.
That's after you subtracted it from the mean?
Yeah.
Uh, Here, let me do it again.
Okay.
I got 88,000.
88,000 even?
88,002.
Okay, that's what I got too.
It's just easier to say the same numbers because if it, all of them, you know.
Yeah.
Okay, what did you guys get for number 10?
88,002. What are you doing? How can we help you?
I don't know. I think I'm doing the math wrong because so I did 1.96 times 36,730 divided by 6.
It's 1.96, not 1.86.
Yeah, I'm doing because it's the from the 95th person.
Yeah. And what did you get with that? What number did you get?
It's like 11,000 or something.
Mm-hmm.
Yeah.
11,998.5.
Mhm.
That's right.
Okay.
And then you subtract that from the mean.
So
So
from
do
100,000.
111,000 minus that number. That's how we're getting our answer.
Okay, I think I was missing a 0 on my 100,000. 998. Oh, no, sorry.
You got it?
Sorry, hold on. I'm doing everything on my phone because my husband has my calculator and my laptop.
You're fine.
9. And I never use this thing for math. So 98 or 98,000. Wait, 988.
Okay, we got 88,002.
Okay. So what did I do wrong?
I'll show you what I'm doing. Just a second.
Here, can you guys give me 1 second?
Yeah.
Hey.
Because I typed in the 1.96 times 36,730 divided by 6, and then I subtracted that from the 100,000.
Okay, so here's what I'm doing. I'm doing
Our numbers right. I don't know.
196 times 36730.
Yes.
Oh, except I forgot my number there because I'm not used to using my computer calculator. 96 times 36730 divided by 6. So
Right.
this number, 11, again, then you subtract that from 100,000. 123 minus 11,998.5 equals 88,001.5, and you have to round it up.
I think I just did my math wrong or something. I typed in the wrong number because I did the same thing except I got 100,000 more than what I should have.
Yeah, probably you added an extra 0 or something.
Yeah. Okay. So it's 88,002.
Yep.
Yep.
And the next one we just add instead of subtract.
And I got
oh, what did you get?
111999.
That's what I got too.
Okay.
So 4 ones and 3 nines?
3 1s and 3 9s.
3 nines. Holy cow.
Just 3 of each.
So you do the same thing except you add the mean.
Yeah.
Yep. Okay. There are three requirements that need to be checked when computing a confidence interval for a mean. And they are, do you have the textbook up?
They're all of the above because
Yep.
there's 3 of them and there's 3 answers there.
Yep.
And
Okay.
I know that those are all true.
Yes, I know too. Okay, submit.
Okay, hold on. What was number 5 again? I think I wrote it wrong.
498.315. That's what I got.
Okay, submit then.
Ugh. Okay, so number.
Still waiting for mine.
Oh,
Loading, submitting. There you go. Oh, okay. So, did we all do the math wrong then, or?
I'm not sure. Okay, Rebecca, are you there?
She's frozen. Becca?
Oh no. Well,
Uh,
can you see me?
what happened? Did
Can you-
she? I think she left.
She didn't mean to. Her computer froze. Ugh.
Oh,
Okay.
she's coming back. No.
Just give her a second. She'll do something.
No. Okay. So
I think what we did wrong though is we used the standard deviation when we should have used the sample size. I think that's what it came down to.
okay. So using the sample size instead of.
Because on number 5, we took the square. Oh, where's my math?
Sample size.
Oh, I don't know where my math is, but we took the square root of the sample size on number 5. Or no.
Yeah, that's what we divided with. Well,
Okay. Well, no. What we did is for number 5, we divided by the square root of the standard deviation, and in number 10 we divided by the square root of the sample size.
oh.
So that's what we did wrong. So, she'll send us another email to get back on, or here, I'll text her and see what happened. So,
I hope it was that and not just a simple math.
no, I think we just got our numbers mixed up.
Yeah.
So, yeah.
So did
There
you
you
guys
go.
finish it up?
What?
Were you guys able to submit it and whatnot?
Yeah. It took a while, but we did it.
Yeah, I don't even know what happened to my computer. I'm using a different computer, and it even died.
Ah,
It just hates me.
Yeah, so we got those two wrong. So what Cassie was saying is that maybe we divided by the wrong number.
do you still have yours up, Rebecca?
Yeah.
Okay. On number 5, we divided by the square root of the standard deviation, and then on number 10, we divided by the square root of the sample size. So those should have been flipped.
Oh. Okay. Sorry.
It's fine.
Okay.
Are we good?
Yeah.
Okay. I will be prepared next time. I'm so sorry, you guys.
That's okay. So when do we want to meet for Thursday?
Thursday. When can you meet?
I'm busy until like 7:10-ish.
Okay, let's plan on 7:10. I don't know if I have a soccer game yet, so I will text you and let you know.
Okay.
But let's plan on 7:10. Does that sound good?
Does that work for you?
7:15.
On Thursday.
That'll work.
7:15, is that what you said?
Yeah,
Yeah.
I think that would work better.
Okay, we can do 7:15.
Okay, on Thursday. Let's plan on that. Okay. Okay, see you
Alright.
again.
Yeah.
Bye.